Imagine an invisible shield protecting your home from harmful invaders. That's what a magnetosphere does, but on a planetary scale. A magnetosphere is a region around a planet where the behavior of the cosmic plasma is controlled by the planet's magnetic field. It's like a bubble that encases the planet, keeping it safe from the relentless onslaught of solar wind. But how does this invisible superhero come to be? It all starts with the planet's magnetic field. As the solar wind, a stream of charged particles released from the sun, meets this field, it's slowed down, diverted, and some of it is even captured, creating this protective bubble. Without it, life as we know it could not exist. The solar wind would strip away the planet's atmosphere, making it uninhabitable. So in essence, a magnetosphere is our planet's very own superhero, constantly battling to keep us safe. Just like any superhero, a magnetosphere has its own unique structure, complete with a cape, shield, and armor. Imagine a cosmic warrior standing guard over its planet. The first line of defense is the magnetopores, acting as a shield, marking the boundary where the planet's magnetic field meets the solar wind. This solar wind, a stream of charged particles ejected from the sun, is kept at bay by this protective layer. Next, we have the magnetosheath, a turbulent region lying between the magnetopores and the bow shock, an area where the solar wind slows down and diverts its path due to the planet's magnetic field. You can think of the magnetosheath as a buffer zone, cushioning the impact of the solar wind. Stretching out behind the planet, away from the sun, is the magnetotail. Like a superhero's cape, it trails behind, carrying the planet's magnetic field lines that have been swept back by the solar wind. It's in this region that some of the most fascinating magnetospheric phenomena occur, such as substorms that can energize particles and send them hurtling towards the planet's poles. But what makes up this superhero's armor? The magnetosphere is filled with plasma, a soup of charged particles trapped by the planet's magnetic field. This plasma originates from the solar wind and the planet's atmosphere, and it plays a crucial role in the dynamics of the magnetosphere. And of course, at the heart of it all is the planet's magnetic field, generated deep within its core. This invisible force field is the lifeblood of the magnetosphere, shaping its structure and driving its behavior. So the magnetosphere is a complex and fascinating structure, tailored perfectly to its role as a protector. Just as a superhero's outfit is designed for their mission, every element of the magnetosphere, from the magnetopores to the plasma, works in harmony to shield the planet from the relentless onslaught of the solar wind. It's a cosmic ballet of forces, a dance between solar wind and magnetic fields, choreographed in the vast expanse of space. Now let's focus closer to home and explore our Earth's magnetosphere. You might not be aware, but our planet is enveloped by a protective bubble, a magnetic cocoon if you will, known as the magnetosphere. This invisible shield extends thousands of kilometers into space, with a tail-like structure on the side away from the sun that stretches out into the solar system. This magnetosphere is born out of our planet's magnetic field, which is generated deep within Earth's core. Flowing molten iron within the outer core drives a dynamo effect, creating an electric current that, in turn, produces the magnetic field. It is this magnetic field that gives rise to the magnetosphere, wrapping our planet in a protective layer against the onslaught of the solar wind. The solar wind, a constant stream of charged particles emitted by the sun, is a formidable force. Yet our magnetosphere stands as a bulwark, deflecting these particles and preventing them from stripping away our atmosphere. It's a silent, ceaseless battle happening right above our heads every second of every day. At the same time, the interaction between the solar wind and the magnetosphere isn't entirely hostile. In fact, it's this very interaction that gives rise to the breathtaking spectacle we know as auroras. When the solar wind manages to enter the magnetosphere, it energizes trapped particles, causing them to spiral along the magnetic field lines towards the poles. As these particles collide with molecules in our atmosphere, they create the vibrant, dancing lights of the aurora borealis and aurora australis. Our magnetosphere also plays a crucial role in ensuring the functionality of our technology. It shields our satellites, which are crucial for communication, weather forecasting and navigation, from the damaging effects of solar radiation. So while we go about our daily lives, Earth's magnetosphere is our silent guardian, keeping us safe from the sun's harmful radiation. It's a testament to the complex and extraordinary dynamics of our planet, reminding us of the intricate systems at work that make life as we know it possible. Thus, Earth's magnetosphere is our silent guardian, keeping us safe from the sun's harmful radiation. But Earth isn't the only planet with a magnetic shield. Let's take a tour of the magnetospheres across our solar system. Starting off with our closest neighbor, Mercury, it might be tiny, but it possesses a magnetic field. Although only about 1% as strong as Earth's, it still manages to create a teardrop-shaped magnetosphere that stands as a defiant shield against the solar wind. Next stop, Venus. Unlike Mercury, Venus lacks a global magnetic field, but don't be fooled. The solar wind's interaction with Venus's thick atmosphere creates an induced magnetosphere, a unique case in our solar system. Moving outward, Mars presents another interesting case. With a weak and patchy magnetic field, Mars has what's known as a remnant magnetosphere, a ghost of a once active magnetic field. This has important implications for the planet's past and future habitability. Jupiter, the gas giant, boasts the largest magnetosphere in our solar system. It's so massive that if we could see it from Earth, it would appear larger than our moon in the night sky. Jupiter's magnetosphere is also home to intense radiation belts and vivid auroras. Saturn, too, has a substantial magnetosphere, second only to Jupiter's. Saturn's magnetosphere is unique because it's filled with material from the planet's iconic ring system. Uranus and Neptune, the ice giants, also possess magnetospheres, albeit with peculiarities. Uranus's magnetic field is tilted, causing its magnetosphere to tumble unevenly through space. Neptune's magnetosphere, on the other hand, is strongly influenced by solar winds due to the planet's distance from the Sun. Wrapping up with Pluto, despite being a dwarf planet, it has been discovered to possess a small and transient magnetosphere, created by the interaction of the solar wind with its thin atmosphere. So each planet's magnetosphere is as unique as the planet itself, shaped by its own specific conditions. Scene script. Have you ever wondered what causes the breathtaking lights of the auroras? Well, you can thank the magnetosphere for that. Let's dive into the beautiful relationship between magnetospheres and auroras. These dazzling light shows in the sky, commonly known as the northern and southern lights, are not just a spectacle to marvel at, but also a visual testament to our planet's magnetic field at work. But how does this happen? Well, the story begins with the solar wind, a stream of charged particles released from the sun. As these particles approach the Earth, they interact with our planet's magnetosphere. The magnetosphere, being a protective shield, deflects most of these particles. However, some particles manage to seep through and get funneled along the Earth's magnetic field lines towards the poles. Once these charged particles reach the Earth's upper atmosphere, they collide with atoms and molecules such as oxygen and nitrogen. This collision excites these atoms, causing them to light up. The result? A mesmerizing dance of lights we know as auroras. The colors of the auroras, ranging from green, red to purple, depend on the type of gas particles involved in these collisions. Oxygen gives off a green or red light, while nitrogen produces blue or purple light. But auroras are not the only phenomena resulting from the interaction between the magnetosphere and solar wind. Other magnetospheric phenomena include the formation of radiation belts and magnetospheric substorms. Radiation belts are zones of charged particles trapped by Earth's magnetic field. They pose a significant threat to satellites and astronauts in space due to their high-energy particles. Magnetospheric substorms, on the other hand, are short-lived disturbances in the magnetosphere caused by the influx of solar wind energy. These substorms can intensify auroras, making them visible even at lower latitudes. Isn't it amazing how something invisible can create such visible and beautiful phenomena? Now, let's venture beyond our solar system to explore magnetospheres around exoplanets. As we journey beyond the fringe of our solar system, we discover that magnetospheres are not exclusive to our planetary neighborhood. In fact, scientists have found evidence of these magnetic shields around exoplanets, planets that orbit stars outside of our solar system. These discoveries are not just exciting, they're significant in expanding our understanding of the universe. How do we detect these far-off magnetospheres, you might wonder? Well, it's not an easy task. The primary method involves studying stellar radio emissions. These emissions can hint at the presence of a planet's magnetosphere as it interacts with the star's magnetic field. It's like listening for echoes in the cosmic dark. Let's take the example of the gas giant Tau Boo b, located approximately 51 light-years away from Earth. Astronomers have detected magnetic interactions between this exoplanet and its host star, suggesting the presence of a magnetosphere. This is a remarkable finding, as it not only confirms the existence of magnetospheres beyond our solar system, but also opens up new avenues for studying these distant planetary shields. What's more, exoplanetary magnetospheres hold clues to potential habitability. Just as our Earth's magnetosphere protects us from harmful solar radiation, an exoplanet's magnetosphere could shelter potential life forms. So, by studying these magnetic fields, we're not just learning about distant planets, we're also exploring the possibility of extraterrestrial life. But our understanding of exoplanetary magnetospheres is still in its infancy. Each discovery brings forth more questions than answers, making this a thrilling frontier of planetary science. As we continue to refine our detection methods and gather more data, we can look forward to unraveling the mysteries of these distant magnetic shields. So even light years away, magnetospheres continue to play a crucial role in shaping planetary environments. Ever wondered what makes a planet habitable? Well, the presence of a magnetosphere could be a key factor. Imagine a shield, invisible yet incredibly powerful, that's constantly working to protect the planet from harmful solar winds and cosmic radiation. That's the magnetosphere for you. It's like the ultimate guardian, keeping the planet safe and habitable for life as we know it. Now, you might be wondering, how does a magnetosphere do this? The answer lies in the magnetic fields generated by a planet's core. These fields extend into space, creating a protective bubble, the magnetosphere, that deflects high-energy particles from the sun and cosmic rays. But it's not just about deflecting harmful radiation. The magnetosphere also plays a vital role in maintaining a planet's atmosphere. By preventing solar winds from stripping away the atmospheric gases, it helps sustain the conditions necessary for life. Take Earth, for example. Our planet's magnetosphere has been instrumental in preserving our atmosphere, and with it, the conditions for life to flourish. Without it, we might have ended up like Mars, a planet that scientists believe once had a magnetosphere and a thicker atmosphere, but lost both over time. And speaking of other planets, the study of magnetospheres isn't limited to Earth. In fact, it's a crucial aspect of space exploration and the search for habitable planets. By studying the magnetospheres of exoplanets, planets outside our solar system, scientists hope to gain insights into their potential for supporting life. But let's not forget, magnetospheres aren't just about protection and habitability. They're also responsible for some of the most spectacular phenomena we see in our skies, the auroras. These dazzling light shows are actually the result of solar particles interacting with a planet's magnetosphere. So the next time you enjoy a sunny day, remember to thank our planet's magnetosphere for making it possible. Let's take a moment to appreciate the space missions that have helped us understand these magnetic superheroes better. The exploration of magnetospheres has been a thrilling journey. Our understanding of Earth's magnetosphere has been largely shaped by missions like Explorer-1, our first satellite that detected the Van Allen radiation belts, and the International Geophysical Year, a global effort that led to the discovery of the magnetosphere itself. Then we have the Cluster mission, a quartet of spacecraft launched by the European Space Agency, which has been circling Earth for more than 2 decades. This mission has been instrumental in studying our planet's magnetic environment and its interaction with the solar wind, providing invaluable data on phenomena like magnetic reconnection and auroras. Beyond Earth, the Voyager missions have given us insights into the magnetospheres of other planets in our solar system. Voyager 1's flyby of Jupiter in 1979, for instance, revealed the existence of the planet's enormous magnetosphere, the largest structure in our solar system. Similarly, the Cassini mission to Saturn has expanded our knowledge about the ringed planet's complex magnetic environment. Looking forward, the upcoming Jupiter Icy Moons Explorer mission, or JUICE, aims to investigate the magnetospheres of Jupiter and its moons, promising to further deepen our understanding of these magnetic fields. The study of magnetospheres is not just confined to our solar system. With the advent of exoplanet detection missions like Kepler and TESS, we are beginning to explore the possibility of magnetospheres around distant worlds, opening up exciting new frontiers in magnetospheric research. These missions, past, present and future, play a crucial role in our quest to understand magnetospheres. They help us unravel the complexities of these celestial shields, and their insights have broad implications, from understanding the conditions necessary for life to protecting our technology in space. With each mission, we peel back another layer of the magnetosphere's mystery, bringing us one step closer to understanding these celestial shields.